Hello interwebs, welcome to Let's Fix Computers. We've got a Dell Inspiron 7520 here with no power. So I've got the customer's charger here. They said apparently the light goes out when you plug it in, but there's... oh no, we have got a light on the charger. So let's just see what happens with that. So I'll plug the charger in. We have a light on the charger. Bearing in mind that the light on the charger doesn't necessarily mean anything, so take that with a pinch of salt. We plug it in. Okay, and the light on the charger went out immediately. So, okay, and the light on the charger has not come back on. So unplug that and plug it back in again. Okay, and it comes on if we disconnect and reconnect the charger. So this is going to be a short circuit in the system somewhere. The question is whether it's the charger or the laptop. So first things first is we're going to grab another charger and see if that one works. So off we go to the charger wall. Okay, so ancient old Dell charger, green light on the charger, green light goes out when we plug it in. Okay, so the fault occurs with a known trusted charger. Therefore, it's not the charger, it's the laptop. So, right, first things first then, we're going to strip this thing down and do a visual inspection around the charger jack to see if we can see any obvious faults with it. Okay, let's do this. Okay, right, so here is the back of the power jack. There's no visible problems there. Let's get the multimeter. Okay, so firstly we're just going to run the multimeter in beat mode and check if we have a direct short to ground. Which we don't. So we're not directly shorted to ground, although there is 25 kiloohms between ground and main, which seems kind of low, but I don't know what it should be. So we'll take that with a pinch of salt. What I'm going to do, I'm going to disconnect the power jack, and we're going to plug the charger into the power jack and see if the fault is still there. Okay, so with the DC jack disconnected, when we plug the charger in, the light does not go out. So it's not a fault with the jack. So that means it's a fault on the motherboard, which is pretty bad news. Let's take this motherboard out and do an inspection on the other side and see if there's anything to see there. Right, I just tested the resistance to ground on a couple of other dead motherboards, on some motherboards that I had on the walls and stuff like that, and I was seeing resistances ranging from 50 kiloohms to 160 kiloohms. So 25 kiloohms drop to ground definitely seems on the low side for this. So I think we do have a short to ground. So we need to see if we can find out where that is. Right, looking on the other side of the board, there's nothing immediately jumping out at me there. So let's plug the DC jack back in. And firstly, let's make sure that our short is still present. Yep, so about 21 kilo ohms, which is fairly high, but that still seems too low for the total sum of the system. Okay, so we've taken this board out and I've done a visual inspection on the general region around the DC in jack, and I'm not seeing anything that's jumping out at me that says I'm broken or anything like that. The DC in jack comes in here, and then we've got a lot of sort of power stuff around this area and also on the other side of the board around this area here. Now this fella here, that's a coil. That's almost certainly going to be our main input coil, because on most Windows laptops you'll have the DC in jack, then a coil to smooth out the flow, and then that then goes to all the charging and power control stuff. So what we're going to do is we can use this to identify where we are on the board. Now, I did a little bit of Google search and I actually managed to find a schematic for this laptop, which we'll just switch over to now. And what I did was I searched for that coil, which is labeled PL901. So I then searched for PL901, and that brought us to this page here. And if I scroll down a little bit, as you can see, we've got power, DC in, battery connection, etc. So we're in the right place. So in the top left here, you can see there's our DC in jack, and that then goes through a coil, which is our PL901 coil, and then it goes to voltage in, V in. So I've already checked these capacitors, and none of them are shorted to ground. Otherwise we'd have just a flat short anyway. So the problem is that when I start scrolling through this, we'll start seeing that VN goes to a lot of places. We've got it here, we've got it down here, and if I keep scrolling a bit further, we can see we're now getting into the battery charger area, which is VN, 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 and you get the idea. So this is turning into a bit of a ball ache at this point. So what we're going to do, we're just going to try and cut off VN from some of the big main places and just see how that affects things. And yeah, we might get somewhere. So if I roll back up to here, we've got the source of V in. Then on most systems we will find some overcurrent protection systems. So this is probably one here for battery stuff. And then we've got a double current control system here for the battery charger. And let's see if we can see any more obvious ones. I might have to do some more scrolling. Then it looks like everything else from this point onwards is now all powered by different rails. So we could just scroll through and see what else VN is powering and just disconnect all of those and see if our short disappears. So let's do that. So I say short, but as I say, let's see if the charger stops cutting out on us. Because I mean, obviously if we take stuff off the board, that will kill the board, but at least if the charger isn't cutting out, it means we're actually getting somewhere. It means we've actually got half a chance of tracking down what's really wrong with this thing. So let's scroll back up to the top from the source of VN, and we're going to search for VN. So there's our first instance. I'm going to go through and disconnect this from anywhere we can. So first point there. Then we've got here, this goes through to this rail here. So we could take out PD906 if we can find it. Not all the components on this board are labelled. What's that nearby? It's near PQ905. We could probably find that. That's going to be a large unit. And then that looks like it all goes through and powers this 3-volt rail. So that's a good place to start. So let's find PQ905. Okay, PQ905 is no stuff. There's nothing there. So that doesn't exist. Never mind, we'll move on to the next bit. So this is a bust. This is not here. This is all no stuff. ERP Lot 6 circuit. What does that do? That looks like some kind of power control, PQ907A. However, its path to ground goes through these resistors. If those resistors were shorted to ground or had failed, then they would cut off. They don't short to ground, so that's not going to be it. Could be coming down through this fella here, PQ907. That's PQ907 there. So let's start taking stuff off the board. I'm going to get fairly aggressive with this. We're just going to take stuff off until the problem goes away, and then just start putting things back on again. So let's go. Awesome, I just lost the orientation of it. Okay, no change, the charger cut out. Right, okay, so that went nowhere. What's next? Okay, now we're onto the battery charger. So this circuit is this is the battery charger control chip, and this all runs power through to the battery. So there's our main input up here. So we've got a current control system up here. Now PQ100, as you can see, if we take this out, then it cuts off pretty much the entirety of the circuit. We've got a path to ground through here. We've also got a path to the system through this area. However, if this fella is removed, then none of the circuit is going to power up. And if any of these are causing a problem, then there would be a direct short to ground. So that's not going to be it either. So if we take out PQ100, then that should answer our question as to whether it's the battery charger or not. So let's drop that off the board. So PQ100 is up here. Let's take him out. Okay, connect charger. Hello, the charger light is still on. Charger is connected and we still have a light on the charger, which you can't see from there, but it's there. We are actually getting somewhere. Alright. Okay, so now we're actually getting somewhere. So this fella here is what is causing our problem. So let's have a closer look at this and what it does, and let's see if we can figure this out. So back to the schematic. So we took out PQ100, which is this dude here. So what these two do in tandem is if the current reaches a certain point, they can cut off the power to the system. So the question is whether it's this guy itself causing the issue, or whether it is part of the system that is telling these things to stay open or stay shorted to ground or something like that. So likewise, I'm looking for paths to ground here, and we have paths to ground going through here. If these two open up at the same time and so on. So what I'm going to do first is just simply put this back on the board and see what state it's in. So let's put it back on. Right, firstly let's do a control check. So I'm going to plug the charger back in, and we're expecting to see the charger cut out. And the charger has cut out. So, what's the deal with this guy? Let's see what this does. So firstly, let's just do a sanity check. Does this thing actually have a path to ground anywhere at the moment? Because according to the schematic, it shouldn't have a direct path to ground. That I can see anyway. Because it's got to go through all these fellas first. So Okay, that's interesting. That entire side of it all goes to ground at the moment. So what is that? That's going to be pin 1. Yeah, so pins 1 to 4 are all currently shorted to ground. So how do they get there? Pins 1 to 3 are joined together. Then they come down. They can either go through this transistor and that transistor and get to ground, or they can come through these guys and all the way down here. That's a long way. That's not going to be it. So the most likely culprit is that this thing... No, there's no path to ground through there. It's got to go through the gate. How is that getting to ground? Let's check that again. Let's check the actual resistance here. $40 ohms. So it's going through something to get there. And 2 ohms. It's going through capacitors to get to ground because the resistance is charging. However, it's super low. So there's something funny going on here. So it's kind of going to be a bit of a pain to figure out whether this is our path to ground or not. However, one thing we can consider are what are the alternative paths to ground. So we've got a ground down here going through this transistor, or failing that, there is also this direction out here. And this goes out through these resistors, through some other places, and you know, there's some grounds over here and stuff like that. Now this resistor is kind of a major bridge point here. If we took this out, then we can cut out, let's just zoom out so you can see the big picture again. If we took that resistor out, we kind of cut out this entire block over here. And that leaves this region as the only way that these fellas can be going to ground. So let's take out that resistor and see if the short to ground disappears, because that will tell us whether we should look over on this half or on this half. So let's try that. So that resistor is going to be fairly big. That's PR102. So looking on the board, PR100. There it is, PR102. So let's take that off and see where that gets us. I think we'll just tidy up those pads a little bit because they've been left a little on the rough side, and I just want to make sure that none of those are connected together. Okay, and our short circuit is gone. Okay, so it was on that half of the board. So now we're getting somewhere. Let's put that back on before I lose it. Okay, and with our resistor back in place, our short to ground is returned. So, okay, so where does this resistor go next? Back to the schematics. So that's the resistor that we're taking on and off. So that, it can go this direction down through PQ102 and down there, or it can go through these fellas and go down there, or it can go down in this direction and go to these ground points through here. Or this chip could be shorted to ground. So let's go around clockwise, PQ102, we're just going to brute force this problem. So this fella up here, if we take this out, there is no longer any path going down in that direction. So, and we've also got those down there, good grief. However, again, if we take this one out, then that cuts off all of that and all of that. So that's again another major bridge point. So PQ102, that's probably going to be fairly large as well. What was that? I wonder if that's this one here. Yeah, let's take the heatsink off. Oh, damn it, I was wrong. That's not it. Oh, there's PQ102, it's up here. Alright, so there's the fellas that we're working with, and here's PQ102 up here. So let's drop him off the board. I jumped a foot in the air because there was a crack, and the crack was just my my countertop bubbling. It was not the laptop. Good grief, that scared the life out of me. Whew. Okay, right. Status on our short. Okay, our short circuit is still present, so that's not it. So let's put it straight back on the board again. Stay on topic. Okay, what's next on the agenda? So it's nothing over here. So our next path is these fellas, or maybe down here. PL101, that has a path to ground through these caps if any of those are shorted. We could just run along those caps and see if they are working or not. Let's quickly do that. PL101, where are you? PL101, and we've got a row of 4 capacitors next to it. Those are going to be our guys, and they're all varying in size. So what we're going to do, I'm going to put my multimeter in resistance mode, and as I touch on each one, if they're working, we should see the resistance increasing. So firstly, let's just confirm that these are what I think they are. So we should find that on one side of them, it's all ground. So how about there? Yep, 0 resistance to ground. Yep, so the bottom line is all ground. So now if we check the top, that's charging up. Although not very much. That's super low. That feels super low. What about that one? Only up to 2 ohms again. Of course, the other way of testing this is just to remove the simply to remove the coil. Let's do that. Let's remove the coil. Ow, everything's super hot. And our short to ground is gone. Something funny's going on here. Right, let's take a closer look at that circuit. So we just took this out and the short disappeared. So we started out up here, we had a short to ground on these overcurrent sensors. When we took this out, the short disappeared. We followed it all the way along here. We followed it through this resistor. We went along there and hit a dead end. So then we came down here, we've removed this one and the short has disappeared. So the short is down this direction somewhere. So these guys have a path to ground, and they seem to be reading a fairly low resistance to ground. But my limited experience doing this is not sure how high their resistance should be. So one thing I could do is find a similar capacitor somewhere else and measure the resistance on that. So what are those? Those are 4.7 U. Let's have a look at some other capacitors. Over here we've got a 2.2 U 25 volt capacitor that is a grounding capacitor. I'm going to quickly check the resistance on that little dude and see what we get, because that might give me a hint as to whether the resistance on these guys is vaguely correct or not. Because 2 ohms to ground, that seems wrong to me. But I could be speaking out of ignorance because I am kind of brute forcing my way through this fault in general. So let's go back over to here and see what this guy measures. So that is near, where are we at? We've got PR100, PR104, PC100 is our capacitor, and this is near PQ100. So let's see if we can find any of that. So PR100, PR104, and then there's a capacitor. I'm thinking it's probably this guy. Let's do some polling. So beep test. So from there to there. Yep. From there to there. And from there to there. Okay, so that's our guy. And that should go to ground. Which it does. So what's the resistance of that? So this, when I check both sides of that capacitor, yeah, see, that's gone straight up into the kilo ohms, you see. That's what I'm expecting to see from a capacitor. And as you can see, it's slowly rising where the capacitor is charging. So these bastards over here, where do we take that thing off? I think we're onto something here. So these guys are all shorted to ground. Those are our culprits. So, or at least one of them is, and that's bringing all the others down with it. So we're going to start taking those off the board until our short disappears. So let's do a quick beep test on that. So we've got a control method. So they're all beeping on ground. So let's take them off one by one. The short has gone. And let's just see what the resistance is on these little guys now. Mega ohms. Mega ohms. Bam. Okay, so let's put the right hand one back on. And kilo ohms. Alright, that's fine. Let's put our coil back on while we're here. Okay, I think it's time to try the charger again. We're just going to double check that that short to ground is gone from the influx, whatchamacallits, which it has. Nice. Okay, plug in. And the charger light is still on. Alright, look at that. So simple. Okay, so we've got a culprit. Now we need a 1U 25 volt capacitor. Okay, right, we are most of the way there now. We just need to tidy up. So I want to tidy up the larger capacitor that I put back on is wonky. I want to straighten that up, and I need to put on PQ907 as well, which we took off the board earlier on. So we're just turning the equipment back on, and we're going to straighten that stuff up. Okay, right, let's review. So firstly, there is no longer a short to ground on these fellas. Whoops. Lots of kiloohms. And also, if we measure across the jack, we now have a lot of kiloohms to the tune of 150. As opposed to like 18. So that is our problem solved. Now the cap we've removed, I'm not going to bother replacing it because it's one smoothing cap out of a bank of 4. If that was a single capacitor, if that was like sort of a mission critical thing, I would say okay fine, I'll order one capacitor off the internet. However, because that is just one tiny little smoothing capacitor, I don't care. So we're leaving that off the board. This thing is almost certainly going to be fine. We'll find out when we see if it charges or not. If it doesn't seem to want to charge, then that's obviously going to be causing a problem. However, I'm willing to bet money that when I put this thing back together, that's going to work just fine. So let's get the alcohol and just tidy up a little bit of that flux, and we'll reassemble. How annoying. This thermal paste has gone hard, so it's got to go. I never actually needed to take the heatsink off in the end. Okay, right, moment of truth. Charger light is on. Plug in charger. Charger light is still on. There's no light on the front of the laptop, but we've got no battery connected. Does the laptop turn on? Shazam. It lives? It lives. Checking media. Cool. Right, I'm going to power that off again. Now comes the scary bit. We're going to connect the battery. So battery in the bottom. Ugh. Right, charger light is on. Bam! We have a battery light. It hasn't turned orange, it's just white at the moment, so I don't know if the battery is charging or not. I think we're going to need to get into Windows or at least BIOS to find out, so let's hook up the keyboard so we can get into BIOS, and that will tell me. Okay, here goes nothing. Power. F2 for BIOS setup. And oh, that's annoying. This one doesn't have any information on battery health. This battery is performing normally. Okay, it's not what I was hoping for. Some Dell laptops normally give you a more graphical display that actually tell you a bit more about the condition of the battery. It looks like we'll need to get this thing into Windows to really find out what's going on. So let's power down and reassemble. Well, it's running on the battery, that's a good sign. Let's turn that off. Let's properly reassemble this, and I think I'm going to risk that. Right, we were so close. I'd recorded the outro and everything, but we do not have a 100% fix on this thing. However, I'm going no further with it, and I'll explain why in a moment. Firstly, I'll just show you what stage we're at. We can now plug in the charger. Light on the charger stays on, it's fine. The computer starts and runs. However, observe now, I turn the laptop on. We'll just drop it into BIOS setup so it doesn't boot Windows. Now the laptop is turned on, I disconnect the charger and it runs on battery. But if I reconnect the charger while it's turned on, it dies. So we've got a partial fix here. So something in there is still upsetting the charger. However, it only occurs when the laptop is turned on. So basically, in a sentence, we cannot hot plug the charger. If I turn the laptop off, let's disconnect and reconnect the charger. Charger light, we plug it in, and it's fine. And incidentally, the battery charges in this condition as well. You know, we have a charge light on the front and everything. So yeah. Now I'll show you the reason why I'm not going to actually try and solve this any further. Number one, I've spoken to the customer about this, and they said, I always leave it plugged in on the desk, so I don't care. And so at this point, we have a sale on a partial fix. I did him a very cut rate on that because it's not a full fix, so he's gotten a very cheap repair out of this. Now let's go over why I'm not going to go any further with this. So let me just quickly switch over to the desktop setup. So if we go back to the schematic of the battery charger circuit that we've been working on, we can now try and figure out what might be causing this to happen. So firstly, what is occurring here is something is telling the AC to turn off. It's shorting the AC line to ground. Now, this is being done deliberately at this point, because if it was being done by a short to ground or something like that, then that would be relating to, for example, a faulty capacitor or something like that, and the laptop wouldn't switch on at all, which is the state we were in when we first started working on the laptop. However, if we look at in normal operation, what's going to cause the AC to turn off is when this area here gets shorted to ground, and it's going to do that through some of these circuits down here. So these are the protection stuff. Now, the two obvious points are the battery temp signal or the AC off signal down here, which are going to open up these transistors and allow a path to ground from here, which will cut the AC power to ground and kill the charger. So it's not going to be the battery temperature sensor, otherwise it wouldn't turn on in the first place, because the battery temperature sensor is going to be there in standby mode. However, AC off, that is probably the signal that is telling it to go to switch off. And if we trace AC off, we'll find that the source of that signal, if we go Control F here and put in AC off, that comes back down to this fella here. Now, this big ass chip here, this is part of the system management, and it's got loads of interfaces for the keyboard, the trackpad, various power management, general purpose inputs and outputs, and so on. And this is part of the ROM, this is part of BIOS, it's one of the main chips on the board. You know, this is this thing that is generating the AC off signal. So who knows why that has decided to turn off AC power? We don't know. I don't have the parts to replace this, basically. So we're going down a rabbit hole where we know in advance that we have no map and no spare parts at all. So we're at the stage now where I know for a fact that it's not worth pursuing this. Then finally, as the last nail in the coffin, I checked on eBay, and the only replacement motherboard I can find is in China, and it costs £130, which means by the time we've factored in my labour costs for just a straight motherboard replacement, you know, the customer's going to be paying £170 minimum, and they're going to have to wait about a month for that motherboard to show up. So it's not worth it. So bittersweet ending to this video, really. I thought we had a fix. We actually had a partial fix, but we have got this laptop into a condition where it's usable at least. So on that note, I'm ending it. Thank you very much for watching, everyone. I'll see you all next time. Goodbye for now.